Okay, let's look at SJI 2023 prelim question, 2023 prelim exam paper. Okay, so question one, find the gradient of the normal to the curve. Okay, at y equals to equation at x equals to 5, leaving an answer in the form a root 5 plus b, where a and b are constant. Okay, so now over here, right, we have the curve y equals to x to the power of 3 over 2 plus 4x. Okay, they ask us to find the gradient of the normal. What do we need to note about this, right? Okay, is that gradient of normal multiplied by gradient of tangent equals to -1. Okay, so now to find the gradient of the tangent, okay, we have to dy dx. Okay, so dy dx equals to 3 over 2 x over half plus 4. Okay, so then when x equals to 5, dy dx equals to 3 over 2 times 5 to the power of half plus 4. Okay, now since the hint down here is they want us to have root 5, right? Okay, so power half is the same as root 5. So this is technically 3 root 5 over 2 plus 4. Okay, now, and then I'm going to combine them into a single fraction so that I will get 3 root 5 plus 8 over 2. Now, the reason for this will come in the next part, right? Okay, when I want to find the gradient of the normal, right? Now, because I know that dy dx times, okay, the dy dx is my tangent, right? Okay, this one is my tangent. Okay, so tangent times normal equals to -1. So the gradient of my normal, the gradient of my normal will be equals to -1 divides into 3 root 5 plus 8 divided by 2, okay, which is just going to be -2 over 3 root 5 plus 8, right? So you can see the reason why I chose to make it into a single denominator. Okay. Now, in order to get we cannot have a cert as a denominator, so we want to rationalize it because the question wants us to leave it in the form of a root 5 plus b. Okay, so I'm going to multiply by 3 root 5, 3 root 5 minus 8 over 3 root 5 minus 8. Okay, because this is a conjugate set, right? Okay, so multiply the -2 in, so I will get negative 6 root 5 plus 16 over 3 root 5 plus 8, 3 root 5 minus 8, 3 times 3 is 9, 9 times 5, 45, 45 minus 64, that's 19, right? So it goes to this. So separate them out, that I will have negative 6 over 19 root 5 plus 16 over 19. Answer. Okay. Okay, question 2. Integrate 5 over 3x plus 1 minus 4 over 1 minus x squared with respect to x. Okay, so integrate 5 over 3x plus 1 minus 4 over 1 minus x bracket square dx. Okay, very important to write the dx. Okay, so what is it going to be? Okay, so a few things that I would like to do down here is number one, I would like to separate out the integration, okay, because there's a negative sign down here. So I can separate out into integral, take out the 5, okay, 3, 1 over 3x plus 1, okay, minus, sorry, dx, minus integral, take out the 4, 1 minus x bracket to the power of -2, okay, dx. Now, the reason why I'm doing this, okay, actually, no specific reason, right? I just felt that it's cleaner to do it in such a way so that we have a easier understanding, right? Doing integration part by part. Okay, so now over here, right, integrate the 3x plus 1. Now 3x plus 1 down here is a linear form. Okay, so to integrate a linear form, okay, it will be 5 ln 3x plus 1, okay, and then divided by the differential of the inside, which is 3x plus 1, differentiate is 3. So we're going to divide by 3, okay, minus 4. Now, this one, okay, is the algebraic integration, whereby you power up and you divide by the new power, okay? So you have 1 minus x to the power of -1, divide by the -1, multiplied by the differential of 1 minus x, which is -1, okay? So okay, so -1 times -1, nothing happens, right? Okay, and then because this is indefinite integral, so it will be plus c, okay? So final answer, I will have 5 over 3 ln 3x plus 1 minus 4 over 1 minus x plus c. Answer. Okay, question 3. Question 3. Express 1 minus 16x minus 16x squared in the form of a over x plus b squared plus c, and hence state the coordinate of the turning points of the curve. Okay, so let's rearrange the equation. Okay, negative 16x squared minus 16x plus 1 equals 2. Now, when you want to complete the square, it is important to make the first number to be in terms of x squared. So in order to do that, I'm going to factorize out negative 16. Okay, so I will get x squared minus x minus x plus 1. Okay, now sorry, plus x plus 1. Of course, I factorize out negative 16, negative turns positive. Okay, I leave the 1 on the outside, okay, to save some steps. All right, so equals to negative 16 bracket, complete the square, x squared, okay, x plus 1 over 2 square minus negative 16 bracket 1 over 2 square plus 1. Okay, right, shortcut. Oh, so I'll have negative bracket x plus half square minus positive 4 plus 1, so plus 5. Okay, right. Now, from a completed square form, we are able to just observe the turning point, okay, from the effects of completing the square. Okay, the turning points will be, okay, taken from the two values down here, the half and the 5, right? This is going to be a y coordinates of 5, okay, but the half is not exactly half, it's going to be negative half, right? It's going to be the opposite of the bracket. Okay, so opposite of the bracket and the number that follows is my turning point. Okay. Explain why the curve will never intersect y equals to 7. Okay, so that's pretty common sense, right? Okay, so it's going to be pretty common sense after you complete the square. Because when you look at the completed square form, right? Okay, you'll know that for y equals to 1 minus 16x minus 16x squared, it is a maximum point graph. So the maximum point is at negative half and 5. Okay, okay, which means that y equals to 5 is the maximum. Therefore, for y equals to 7, it will never intersect with the curve. Okay. Okay, question 4. The equation of a curve is y equals to a cos bx plus c, where a is greater than 0. Okay, this is crucial information that we need to take note of. A is greater than 0. Okay, now, given that the maximum values and the minimum values are 1 and -9, state the value of a and c. Okay, this is pretty simple. A is the amplitude, right? Okay, so amplitude is the maximum and the minimum together, right? And then you split half each. Okay, so we'll take A equals to -1 plus -9. Wait, sorry. 1 and -9. 1 minus 9 divided by 2. Okay, so that's -4. Okay, now, and C equals to -1. Wait, sorry. This is the, sorry. Okay. Okay. C equals to -1 plus 9. Sorry, keep looking at the wrong value. 1 plus -9 divided by 2. Okay, so equals to -4. Okay, so this -4, right, is the C value. Okay, is the center line. Okay, so the center line is what enables us to find out what is the middle point, right? Okay, of both of the cosine graph. Okay, think of it in such a way. Okay, this C, right, is the vertical shift. Okay, and also the middle point. Okay, okay, or the center line, right? How you want to look at it. Okay, so amplitude is equals to, okay, 1 minus -9 divided by 2 equals to 5. Okay, so therefore, the equation is now y equals to 5 cos bx minus 4. Okay, so once you get the answer, you can also think about it, right? Because cosine itself is 1 and -1, right? So 5 times 1 will have a maximum of 5 and a minimum of -5. So when you minus 4, 5 minus 4 is 1. Minus 5 minus 4 is -9. Okay, so that is correct. Okay. D, given that the period of y is pi, okay, find the value of p. Now, what does it mean? Okay, right? So value of y, okay, sorry, I had a work call, right? Okay, given that the period of y is pi, find the value of p. Now, what is period, right? Okay, period is how much angle, right, is needed, okay, or how much radian is needed for one cycle. Okay, so given that the period of y is pi, right, what it means is that the cosine curve completes itself in pi. Okay, but a normal cosine curve will only complete itself in 2 pi. So given that the period is pi, that means the value of p will be 2 pi divided by pi equals to 2. Therefore, y equals to 5 cos 2x minus 4. Okay, right. As in b equals to 2. The actual answer should be b equals to 2. Okay, so we know that the full equation is 5 cos 2x minus 4. Hence, sketch the graph for x to more than 0, less than 2 pi, labeling the maximum and the minimum point clearly. Now, since the period is pi and they want us to draw until 2 pi, which means that we are supposed to draw 2 cycles. Okay, so here is how I'm going to draw my cosine graph. Okay, so this is x, this is y. Okay, now here, what I'm going to do first is I'm going to mark I'm going to mark 3, maximum, minimum. Okay, try to make sure that they are maximized. Okay, and then over here, okay, sorry, this one shouldn't be the x-axis. Okay, I should remove this first. Okay, but I'm going to make this, okay, with pencil drawing, right? So pencil drawing, okay, I'm going to label this as 2 pi. Okay, this is going to be my 2 pi, but in pencil, okay, in pencil, right? So 2 pi, try to find the midpoint. This is going to be pi. Okay, at the angle, because I know that this one will complete a cycle by itself. So I make a mark, okay, half of it, half again, half again. Okay, now cosine curve starts from the maximum. Okay, so here we can mark it properly. Starts from the maximum, goes to 0, goes to minimum, goes to 0, go back maximum. Okay, same thing, right? This one, okay, cut into 4 as well. Okay, start from maximum, goes to 0, goes to minimum, goes to 0, goes back maximum. Okay, so I have all my points plotted out. Okay, so now I can draw my cosine graph. Okay, so it's going to look like this. Okay, so yeah, that. Okay, now, however, right, okay, the maximum point is 1, the minimum point is -9. This line that I've drawn, okay, is the center line, which is -4. Okay, so need to keep that in mind. Okay, now afterwards, I'm going to take my eraser. Okay, I'm going to do something. Okay, I'm going to make sure that this line, okay, not that it disappears, okay, but I'm going to make it into a dotted line, right? Okay, okay, because this line shouldn't be the axis, oh, but I use it as a helping, okay, as a help. Okay, right? Okay, hope you I can understand. Then now I will draw the actual axis. Since this is 1, 0 should be somewhere over here. Okay, then here, then I will draw in the real axis. Then I'll put in the points that is needed. Okay, which is over here. This is going to be 2 pi, and then this is pi. This is pi over 2. This is pi over 4. Okay, 3 pi over 4. Okay, then this is uh 4 pi over 4, 5 pi over 4, okay, 3 pi over 2, 7 pi over 4. Okay, that will be a nice cosine curve. Okay, hopefully this is, okay, you can understand the logic of this. Okay, let's look at question 5. The function fx equals to ax cubed plus 5x squared plus bx plus 1 has a factor of 2x minus 1 and leaves a remainder of 9 when divided by x plus 1. Show that b equals to -5 and find the value of a. Okay, right? So factor and remainder theorem, right? Okay, so fx equals to ax cubed plus 5x squared plus ex plus 1. Okay, since it's a factor of 2x minus 1, so function half is equals to a half cubed plus 5 half squared plus b half plus 1 equals to 0. Okay, right? So simplifying this, I would have 1 8 a plus 5 over 4 plus half plus 1 equals 0. Okay, for better presentation, okay, this. Okay, fx is such that. Okay, now, okay, okay, then the other one is function -1 is such that I will have a -1 cube plus 5 -1 square plus b -1, okay, plus 1 equals to 0. Sorry, equals to 9, right? Equals to 9. Okay, so negative a plus 5 minus b plus 1 equals to 9. So negative a minus b equals to 3. Okay, now here, okay, let me shrink this down a little bit. Okay, so we'll have, okay, multiply by 8. So I'll have a plus 4 plus 10 plus 8 equals to -18. Okay, negative a minus b equals to 3. Okay, simultaneous equation, right? Just sum them up. Okay, I will get 3b equals to -15, b equals to -5. Sure. Okay, which proves that I'm on the right track, okay, which is a good thing. Oh, so minus a minus -5 equals to 3. So negative a plus 5 equals to 3. Negative a equal -2. A equals to 2. Okay. Okay. B. Given that the quadratic expression x squared plus px minus 1 is also a factor of px. Find the value of the constant p. All right. So we know that this is a cubic polynomial, okay, since we know the value of a and b. So fx is now equals to 2x cubed plus 5x squared minus 5b, right, plus 1. Okay. Now, since it's a cubic polynomial, that means that it can be made up of two ways, right? Either it's made up of a linear and a quadratic, or linear, 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 right? In this case, they are telling us that it is a linear of 2x minus 1, because 2x minus 1 is a factor, leaving us with quadratic, right? X squared plus px minus 1. Okay, right. Oh, so to find the value of px, I can do two things. Okay, either I can do comparison or I can do long division. Okay, now I think a lot of people will choose to do long division because it's the most straightforward method. Okay, so 2x cubed plus 5x squared minus 5b, minus 5x plus 1. So, okay, 5x. Okay, divided by 2x minus 1. So we have 1, not 1, x squared. Okay, so we get 2x cubed minus x squared minus, okay, 5x squared minus negative x squared, 6x squared, bring down minus 5x, so plus 3x, 6x squared minus 3x, minus again, okay, so we get negative 2x plus 1, so minus 1. Negative 2x plus 1, which fits into this, right? So therefore, by observation, p equals to 3. Okay. Question 6. Express this in partial fractions. First thing first, let's look at the degree. This is x cubed, this is x squared. So that means I need to do long division, right? Again, right? So two long divisions in one. Okay, so I have 3x cubed, 3x cubed minus 4x squared plus 4x minus 17 divided by 3x squared minus x minus 4. So we have x, 3x cubed minus x squared minus 4x minus, okay, minus 4x squared minus negative x squared. So negative 3x squared. Here we'll get plus 8x minus 17. So we have a minus 3. Okay, so negative 3x squared. Okay, sorry, minus 1. Oh, minus 3x squared plus x plus 4. Okay, minus again. Okay, so get rid 8x minus x, so 7x. Minus 17 minus 4, so minus 21. Okay, remainder. Okay, so that means, okay, that this whole thing, 3x cubed minus 4x squared plus 4x minus 17, even before I do partial fractions, all right, it has already become, okay, x minus 1, oh, that's the quotient, plus 7x minus 21 over, okay, factorization of this, okay, I'll get 3x x minus 4 plus 1, okay, plus 1, okay. So now equals to, okay, then on the side, oh, I'll do the partial fractions of 7x minus 1, 21 over 3x minus 4, x plus 1 equals to a over 3x minus 4 plus b over x plus 1. Okay, so 7x minus 21 is equals to a, x plus 1, b, 3x minus 4. Okay, so okay, when x equals to, okay, this one simple, negative 1. So we'll have negative 28 equals to negative 7b. B equals to 4. Okay, x equals to 4 out of 3. Okay, we'll have 28 out of 3 minus 21 equals to 7 out of 3a. So a equals to negative 5. Okay, so then we'll get x minus 1. Okay, back to the answer. X minus 1 plus a is, oh, sorry, minus 5 over 3x minus 4 plus 4 over x plus 1. Answer. Okay, right. Okay, partial fractions, when we get nice numbers like this, we'll be very happy. Oh, because it's okay, very assuring. Okay, question 7. Okay. The number of bacterial cells n in millions in a circular patch after t hours is given by n equals to ke2t, where k is a constant. The initial number of bacterial cells is 10 million. Okay, explain why k equals to 10. Okay, right? Initial number, right, means p equals to 0. Okay, since the initial number is 10,000, okay, and okay, this is n in millions. Oh, so, okay, so 10, this is 10 million, right? So 10 equals to uh, k times e to the power of 20. Okay, when t equals to 0. Oh, so then e to 2 power 0 is k times 1. 10 equals to k times 1. So k equals to 10. Shown. Okay. Find the rate at which the number of bacterial cells is increasing after 30 minutes. Find the rate at which. Okay. Okay. Since they asked for rate at which is increasing, which means that they want okay, dn dt. Oh, so dn dt equals to k times e 2t times 2. Okay, so 2k, or rather 2 10 e 2t. Now, when t equals to half, right? Because t is in terms of hours. 30 minutes is half an hour. Okay, so dn dt is equals to 210 e 1 equals to, okay, so 210 times e power 1, right? So 54.4 million per hour, because this is dn dt. As the number of bacterial cells increases, the area of the circular patch also increases. Given that 4a equals to n squared, find the rate of change of a after 5 hours, giving our answer in exact form. Okay, so 4a equals to n squared. A equals to n squared divided by 4. Okay, because when we want to differentiate, it will always be, the left-hand side always has to be a singular term. So dA dN is equals to half n, right? Equals to half n. So now to find dA dt, okay, I need to take dA dn multiplied by dn dt. Okay, right? So that means it's equals to half n, okay, half n multiplied by what is dn dt? dn dt is 2k, or rather 2 tan e to t. Okay, and then we want to find when t equals to 5. Okay, dA dt equals to half times n, which is k tan e to t. Tan e to t times 2 tan e to t. Okay, so since they're all multiplicative, half and 2 can cancel off. So tan e to t times tan e to t, I will get 100 e 10, right? Equals to E10 times E10. E10 times, oh, sorry, 20. Or E20. So 100 E20. Okay. Whoa, what is this big number? Okay. Oh, wait, they want exact value, right? Oh, they want exact value. So, yeah, this is my answer. 100 E area, so it's units, unit square per hour. Okay. Okay. Right. Question 8. In the diagram, CR is a tangent to the circle at C, and QR cuts the circle at point A and B. Okay. So D lies on the circumference of the circle. Prove that triangle CBR and triangle ACR are similar. Okay. So when I look at similar triangle, I like to do this, right? 1, 2, 3, 1, 2, 3. Okay. So they say CBR, CBR, and ACR. Okay. D lies on the circumference of the circle. Okay, doesn't really matter. Okay. Okay. So the first thing that we can have is angle BCR, right? Angle BCR equals to angle BCR is position 213, right? So equals to angle CAR. Or CAR. Why? Because these two angles are equal, because angles in alternate segment. Right? So that's one proof. Okay, what else? Angle 3, angle 3. Okay, R. Okay, CBR and A, wait, CRB and ARC, right? Angle CRB equals angle CRB is 132, ARC, common angle. Therefore, similar by A. Okay. Given that angle ADB equals to angle BRC. Okay, BRC is this angle. So just now we proved that BRC is equals to CRA, right? CRA is, wait, this is the same angle, right? This is common angle. Okay, so they're telling me that this angle is equals to angle ADB. So this angle, they are the same. Okay, how does that help me? Show that AC is a diameter. Okay, so if these two angles is the same, that means this angle and this angle is also the same. Okay, because angles in the same segment. Okay, and this is angle, this is a diameter, I mean, this is a tangent, okay? But tangent to circle doesn't prove that it's right angle. What am I missing? Let's see. Okay. So we know that, okay, let's call this, okay, a bit confusing. Let's call this angle X. Let's call this angle, okay, this angle is also X. This is angle Y, angle Y, angle Y. Okay, so we have proved that these are the angles. Okay, then this angle is, okay, if this angle, that means this angle is also X. Okay, so that means this angle is also X plus 1. Ah, okay, then that's a proof, right? Okay, so if you are confused at what I did, okay, let me redo the thought process. Okay, now because this is cyclic quadrant, okay, 4 points on circle, right? Which means that this angle ADC is equals plus angle ABC will add up to 180 degree. Okay, so these two angles will add up to 180, but this angle lies on a straight line. Okay, so this red angle plus this open side down here will also be 180. So that means these two angles must be angle X and angle Y. Okay, all right. So okay, let's write down the proof. So firstly, where did we start off with? ADB equals to BRC, right? So angle, okay, okay. Angle CAB equals to angle BDC. Okay, angle in same segment. Oh, okay, let it be. Let angle CAB be X. Okay. Now, and then we also have uh angle ADB equals to angle BRC. Okay, called given by the question. Let angle ADB be 1. Okay, therefore, for 4 marks. Okay, therefore, angle CBR, okay, is equals to angle X plus angle Y, or angles in opposite segment. Okay, right? So we'll have angle, okay, sum of angles in triangle in triangle equals to 2x plus 2y equals to 180. So angle x plus angle y equals to 90 degrees. Okay, cos just divided by 2. Okay, and then, right, what can we continue with? Because you can see that this is angle x plus angle y from the very start, right? You can see this, right? This is angle x, this is angle y. So angle x plus angle y equals to 90 degrees, which means that AC, okay, is perpendicular to CR. Okay, therefore AC, right? This is tangent property, right? Tangent perpendicular to radius slash time. Okay, therefore AC is a diagonal. Okay, because it's a straight line. Okay, question 9a. Prove the identity cos theta over 1 plus sin theta plus 1 plus sin theta over cos theta equals 2 secant theta. This looks easy, right? So some observation we can make. Left hand side got 2 terms, right hand side got 1 term. Okay, so the thought process is to just cross multiply, right, on the left hand side. Okay, so left hand side equals to cos squared theta plus 1 plus sine theta squared over cos theta bracket 1 plus sine theta. Okay, I'm not going to expand the bottom. Okay, so then we'll have okay, expansion, right? Cos squared theta plus 1 plus 2 sine theta plus sine squared theta, okay, over cos theta bracket 1 plus sine theta. Now, some people ask, right, why don't I expand in? Okay, because I consider my left-hand side, right? 2 secant theta is what? 2 over cos theta, right? In my mind, right, I already know this, like, this is 2 over cos theta. So when I have the cos theta down here, right, I don't need to expand it. In fact, what I should do is to actively try to look for ways to cancel away the 1 plus sine theta, okay? So equals to cos squared plus sine squared, that's 1. 1 plus 1 is 2. So 2 plus 2 sine theta over cos theta, 1 plus sine theta. Some of you might have seen it already. So this one, I factorize out the 2. 1 plus sine theta over 1 plus sine theta cos theta. Okay, so cancel, cancel. Equals to 2 over cos theta equals to 2 secant theta equal right hand side. Okay. Hence, solve the equation, right? Trying to confuse us equals to 5. Okay, so over here, what we need to take note, right? That this is actually, okay, they always try to play around with the angle, right? So this is, imagine that this is x. Then it will be exactly the same as the one above, right? In which this whole thing, okay, so we can say from A, okay, we can see that cos theta over 2. Okay, let's just entertain them. Write down the equation first. Sine pi over 2 plus 1 plus sine pi over 2 over cos pi theta over 2. All right. Okay. Equals to, okay, uh, 2 secant theta over 2. Right, for part A. This is my observation. So 2 secant theta over 2 equals to 5. Right? So secant theta over 2 equals to 5 over 2. Secant is the opposite of cosine, so cosine pi over 2 equals to 2 over 5. Okay, now over here, I'm ready to take the inverse, okay, for cosine. Okay, I'm ready to solve. So once I'm ready to solve, I need to consider 3 things. Number 1, range. Okay, theta is in between 180 to negative 180. Okay, so that means theta over 2 would be 90 degree to negative 90 degree. Now, 90 degree to negative 90 degree, right? Actually, just means that we have answers in quadrant 1 and quadrant 4. Okay, as in the range, right? It's only quadrant 1 and quadrant 4. Okay, we don't consider outside of it. Okay, now, and then second thing we need to consider is the agility, right, of the answer. Okay, cosine theta equals to 2 over 5. So the quadrant itself, okay, is indeed 1 and 4. Okay, so that means when we look at the range and the quadrant, we will be expecting 2 answers. Okay, now lastly, to find the basic angle. So basic angle, okay, is equals to, right, this is in degree mode, so make sure our calculator is in degree mode. Cosine 2 over 5, inverse 2 over 5. Okay, so I get 66.421, 66.421. So theta over 2 equals to 66.421 or negative 66.421. So theta equals to times 2, 132.8 degree or negative 132.8 degree. Answer. Okay, next question. Question 10. Given that log 8x plus log 2 1 minus y equals to 1, express y in terms of x. Okay, so logarithm usually just have two ideas, right? Either whether the base are different or whether the base are the same. Okay, if the base are both numbered base, right? Okay, we'll just do cancellation. If the base is x versus non-x, then that would be substitution. Okay, usually that's the two logic. So now we have log 8x plus log 1 minus y equals to 1. Okay, so change of base, log 2x over log 2a plus log 1 minus y equals to 1. Okay, so log 2a, this is equals to 3, right? I can make a mental note. Okay, to multiply the 3, then I will have log 2x plus 3 log 1 minus y equals to 3. Okay, now then over here, right? Okay, what can we do? Okay, uh, okay, I can bring, since I want to make y the subject, so I can bring the log 2x over. So I will have 3 log 1 minus y equals to 3 minus log 2x. Okay, right. Now, what is 3? Okay, so in order to cancel, both sides must only have a single log. So 2 log 1 minus y equals to log 8, right? This is log 8 minus log 2x. Okay, combine the logs. Okay, log 1 minus y cubed equals to log 8 over x. Okay, so now strike off the log 2. I will have 1 minus y cubed equals to 8 over x. 1 minus y equals to cube root of 8 over x. So y equals to 1 minus cube root of 8 over x. Answer. Okay. Okay. B. Solve the equation 5 to the power of 2x minus 3 over 3 to the power of x equals to 2. Okay. So over here, okay, what can we do, right? Now, here we'll have to separate out 5 to the power of 2x minus 3 over 3 to the power of x equals to 2. Okay, so exponents, okay, one of the things that is different from E math, right, is that for A math, exponent is about the separation. Okay, so over here, right, okay, the 5 to the power of 2x minus 3, I can express it as 5 to the power of 2x times 5 to the power of negative 3. Okay, over 3 to the power of x equals to 2. Now, once I separate this out, I know that this is a value itself. Okay, so then I can simplify this as well into, so two things I can do down here. I can have 5 to the power 25 to the power of x over 3 to the power of x, okay, multiplied by 1 over 125 equals to 2. Okay, right? So then, okay, what will I have down here? Cross multiply the 125, I will have 25 over 3 power x equals to 250. Okay, take logs or ln at both sides. X ln 25 over 3 equals to ln 250. So x equals to ln 250 divided by ln 25 over 3 equals to, okay, ln 250 over ln 25 over 3. Okay, so 2.60, right? 3 as okay. Question 11. Right. The diagram represents the circular cross-section area of a commercial plane with center O. Cargo is stored in the rectangular container in the lower half of the plane, touching the fuselage at point P and point Q. The plane is 6 meters wide and the width of the rectangular container is 2x. Okay. show that the area of the cargo container is given by A equals to 2x times square root 9 minus x squared. Okay, right. Plane is 6 meter wide, O is the center, which means that, okay, down here, this part, the radius is going to be 3 by 3. Okay, so that's the gathering that we can have. Okay, so in order to, okay, so we also know that this is the center. So center to point of circle is also going to be 3 meters, 3 meters. Okay, and they did mention that this is rectangle. Now we know that area is given by length times breadth. We have the length as 2x. Okay, which probably accounts for the 2x down here in the area, which means that area, which is length times breadth, this must be breadth, right? This must be the breadth. So that means I want to find the breadth. Okay, so now how to do? All right, so since this is isosceles, right, what means that this is x. Okay, then we have it, right? So the height of the rectangle will be based on Pythagoras theorem by Pythagoras. We'll have the height, okay, or the breadth is equals to 3 squared minus x squared root. Okay, equals to square root 9 minus x squared. Okay, so therefore, area equals to length times breadth equals to 2x multiplied by 9 minus x squared. Or should. Okay. Given that x can vary, find the stationary value of A and determine its nature, right? So two questions down here. Stationary values of A means dA, d whatever, dx equals to 0. Determine the nature means to determine whether dA, d2A, dx squared is bigger than or lesser than 0, right? Or we can also use the first test, right? Depending, or I haven't determined yet, right? So find the stationary value first, okay? So since we know that A is equals to 2x square root 9 minus x squared. Okay, now a lot of people will just do product rule for this. Okay, nothing wrong. Okay, do I have a different method for doing this? Yes, I do. Right? Okay, so now back to cert, right? Okay, we know that a cert, okay, can be simplified. Like for example, square root 18 can be taken as square root of 9 multiplied by square root of 2. So you can write it as 3 root 2. Okay, so that means 3 root 2, I can build it back into square root 18. And that's what I'm going to do down here. Okay, so that I don't need to do product rule for this. Okay, is it good? Okay, I'm not sure, right? Okay, but okay, it's worth a try. So let's try. 2x squared is 4x squared. So square root of 4x squared multiplied by square root of 9 minus x squared. Okay, so that means, okay, if I put it back in, that will be 36x squared minus 4x square root. Okay, so dA dx, okay, equals to 36x squared minus 4x4 to the power of half. Okay, sorry, this is not the dx. Okay, so this is just A. So dA dx is equals to half bracket 36x squared minus 4x4 to the power of negative half multiplied by the differential that is inside, which is 72x squared, so into 2x, okay, minus 16x cubed. Okay, so I'll get okay, 72x minus 16x cubed over 2 bracket 36x squared minus 4x4. Okay, right. Oh, okay, I probably can simplify this, okay, but okay, I'm not going to do that. Oh, so dA dx equals to 0. Okay, so now we want to solve when dA dx equals to 0. dA dx equals to 0 would means that 72x minus 16x cubed equals to 0. Okay, so 16x cubed equals to 72x. Okay, so okay, we can conclude x equals to 0, or okay, actually, you know what? Let's erase that. Okay, maybe I should simplify down here. Okay, by factorizing out the x. Okay, so take out a common factor as well. 8x, 9 minus 2x squared. Okay, over 2x squared bracket, eh, wait, 8x squared. I can factorize out 8x squared. Okay, 8x squared, 9x minus x squared. Okay, so 8x and 8 and 8 cancel, x and x squared cancels. Okay, but anyways, right, back to dA dx, okay, equals to 0. I would have 9 minus 2x squared equals to 0. 2x squared equals to 9. X squared equals to 9 over 2. X equals to plus minus root 9 over 2. Okay, in which we only take positive 9 over 2, right? Okay, square root 9 over 2. Negative, I'll reject it, right? Okay, so, what's next? Determine the nature, right? Okay, I'm probably not going to do the second test, because second test is going to be troublesome, right? So square root 9 over 2 is equals to 2.121. Okay, so now d, okay, so I will have x dA dx and image. Okay, now I know for sure when x equals to square root 9 over 2, we already determined, right? Okay, when x equals to square root 9, so square root 9 over 2, right? dA dx equals to 0, so the line is flat. Okay, now I know it's 2.21, so I'm going to take a value bigger and a value smaller. So bigger, 2.2, smaller, 2.0. Okay, so then sub in into dA dx, right? And see what result will we get. Okay, so when we sub in into the first one, okay, into dA dx, right? So dA dx is equals to these values down here, right? Okay, so mentally calculate, sub into 2 squared, right, is 4. 4 times 2 is 8. 9 minus 8 equals 1. Okay, so top is 1 over x squared is 4. 9x is 18. 18 minus 4 is uh 18 minus 4 is 14, right? So 1 over 14, which means it's positive. So the image of positive is like this. Okay, which really tells me the answer already, right? Okay, positive, go out. Okay, dA dx equals to positive. Now when I sub in 2.2, things are a little bit different. 2.2 square times 2. Okay, what happens? I get 9.68. So which means 9 minus 9.68. The numerator is negative. Okay, 9 times 2.2 square. Okay, 9 times 2.2 only, sorry. Okay, minus 2.2 square. Bottom, positive. Negative over positive. So dA dx is negative. So therefore, okay, square root 9 over 2 is what? Is a maximum. Okay, sorry, I think I forgot to find something as well. They ask for stationary point. Okay, so stationary point, the x value is this lah, huh? Okay, this one no change. Okay, but now I want to find I want to find A, right? A equals to what? A equals to 36x squared minus 4x4 to power half. Okay, 36x squared minus 4x4 to power half. So equals to bracket 36 times 36 times square root 9 over 2 whole square. Okay, then minus 4 times square root fraction 9 over 2 power 4 power 4, okay, 81, and then square root, okay, 9. Oh, so 9 meters square. Okay, right. Oh, okay, question 12. Okay. The curve y squared equals to 2 over 3x plus 2 and the line 3x plus 2, 3y plus 2x equals to 0, intersect at the point A and B. Find the coordinates of A and B. Okay, so pretty straightforward. This is just substitution. Okay, so I'm going to sub the x, not the y, because y still needs to square. So I'm going to make x the subject. Okay, so 2x equals to negative 3y, x equals to negative 1.51, right? Equation 2. Okay, equation 1 is y squared equals to 2 thirds x plus 2. Okay, equation 1. Sub 2 into 1, right? Y squared equals to 2 thirds multiplied by negative 1.5y plus 2. Okay, so y squared equals to negative y plus 2. Y squared plus y minus 2 equals 0. Y minus 2, y plus 1 equals 0. Y equals to 2 or y equal negative 1. Okay, x equals to negative 3 or x equals to negative 3 over 2. Okay, positive 3 over 2, sorry. And so, simple. All right. Okay. Negative 3 over 2. Negative 3. Oh, wait. Oh, wait, sorry. Wrong. Okay. Sorry, the factorization should be y plus 2, y minus 1 equals 0. Y equals to 1. So x equals to negative 1.5. Y equals negative 2. So x equals to 3. Okay. So the curve of y squared equals to 2 over 3x plus 2 is made out of two parts. The parts above the x-axis is given by y equals to square root 2 over 3x plus 2, and the bottom part is given by square root of negative, y equals to square root of negative 2 over 3x plus 2. Okay, the diagram shows the curve y squared equals to 2 over 3x plus 2 and the line 3y plus 2x equals to 0. Okay. Okay, so that means that the intersection is, okay, this is supposed to be negative 1.5 and 1. Okay, and this is supposed to be 3 and negative 2. Right? Okay, find the area of the shaded region bounded by the curve, the line, and the vertical line AC. So C is negative, x equals to negative 1.5. Okay, nothing much. Okay, let's see. Okay, find the area of the shape. So I have okay. So let's tilt the image to understand it a little bit better. Okay, so we can do this. I mean, okay, for you can just tilt the paper, right? Okay, so basically, right, okay, we can look at it in such a position. Oh, okay, so try to think of this as your new x-axis, and then this is your new y-axis, sort of, right? Okay, if you think of it in such a way, then the area would just be, okay, area on the graph from here, okay, so it's line from here to here, and then curve, okay, line over that's line minus curve, okay, is that a line from 3 from, okay, let me look at the question. Okay, so, right, okay, we can do this, right? Okay, so we'll just apply line, curve, right? This is the curve, okay? So line is above the curve, we just have to integral, okay? Line minus curve, all right? So that will be equals to, B is 3, A is -3/2, okay? Of the line, okay, that we need to convert, 3y plus 2x equals to 0, 3y equals -2x, y equals to -2/3 x. So when they integrate -2/3 x dx, okay, minus integral, same point, -3 plus 3 to -3/2 of the curve, okay, negative square root 2/3x plus 2. Okay. However, right, okay, this negative sign is a constant, so we can factorize out affecting this negative sign, okay, so that we can have equals to, since they are the same point, we can combine them, right? 3/2, 2/3 x plus 2/3 x plus 2 to the power of half dx. Okay, right? So integral of this, okay, we'll get 2/3 x squared divided by 2. So this 2 cancels out, plus 2/3 x plus 2 to the power of 3/2 divided by 3/2. Okay, right? Multiplied by the differential of the inside 2/3, which then cancels out to be 1 as well. Okay, to the power of 3 -3/2. Okay, so then we'll get, okay, make things a little bit clearer. 1/3 x squared plus x plus 2, sorry, 2/3 x plus 2, 2/3 x plus 2 to 3 and -3/2. Okay, so sub into the calculator, we'll have, okay, 1/3 times 3 squared plus 2/3 times 3 plus 2, 7. Oh wait, sorry. What am I doing? Sorry. Okay, again. Okay, sorry, it's a little bit untidy. So it's 1/3 x squared plus 2/3 x plus 2 to the power of 3 over 2 to 3 and negative 3 over 2. Okay, so then we'll have, okay, minus second portion, which would be equals to 1/3 times 3 square plus 2 over 3 times 3 plus 2 to the power of 3 over 2 minus bracket 1 over 3 times negative 3 over 2, okay, negative 1.5 square plus 2/3 times negative 1.5 plus 2 power 3 over 2, close. Okay. Aquí tengo mucha más. It's 2/3 x plus 2 negative. Oh, wait, this is 1/3 3 square plus 2/3 times 3 plus 2. So that's 4, 9. 9 plus 3, 12 minus 3. No. Wait, sorry, this is supposed to be minus. Hmm? Okay, this is plus. Minus. Okay, wait, let me try with key again. 1/3 times 3 square 1/3 times 3 square plus bracket 2/3 times 3 plus 2 power 3 over 2. Okay, 11, right? Okay, then we have 1/3. Oh, wait, that was a mistake here. This is negative. Negative 1. Oh, wait, so this is 5. Okay, then this is negative 1.5. Okay, 4.75 meters. Okay, 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 all right. Question 13. The diagram, which is not drawn to scale, shows the line L1 equals y equals to 2x plus 3 and L2 y equals to minus 3x minus a. Lines L2 and L1 intersect at point A and point point B at point C lies on the y-axis. Given that the area of triangle ABC is 10 square unit, show that A equals to 7. Okay, so that this coordinate is 0 and negative A. B coordinate is 0 and 3. Okay, now since both line meets at point A, so we can also say that 2x plus 3 equals to minus 3x minus 8. So 5x equals to uh, minus 3 minus a, x equals to minus 3 minus a divided by 5. Okay, at least that's the x coordinate, right, for now. Okay, so now since the area is 10, okay, the difference between these two areas will be 3 minus a, right? The difference will be 3 plus a, all right? So half times 3 plus a times minus 3 minus a over 5 equals to 10. Okay, so we'll have 3 plus a multiplied by minus 3 minus a, okay, equals to 100. Okay, so negative 3 plus a squared equals to 100. How does that make sense? Did I make any mistake? Let me check. 3 plus a, 2x plus 3 equals to minus 3 minus a. 5x equals to minus 3 minus a. Oh, sorry. Oh, okay. I understand why already. Okay, because this one is negative 3 plus a over 5, right? Because this is in the negative aspect of the coordinate. So we don't need to discount, we can discount away the negative sign. Okay, so that means, okay, it's supposed to be without the negative sign. So 3 plus a squared equals to 100. 3 plus a equals to 10 or negative 10. So a is equals to either 7 or negative 13, which has to be rejected, right? Because a is supposed to be a negative value. I mean, a is supposed to be a positive value because negative a should be negative. Okay, if negative a equals 13, it doesn't make sense, right? So negative 13 is rejected. Okay, so that means we found two things at the same time, right? So we get that the C is actually 0, negative 7, and A is actually equals to 3 plus 7, then 10 divided by 5 is 2, so it's negative 2, and Y is negative 1, right? So A is the point, negative 2, negative 1. Okay. Given that line 3 passes through B and is perpendicular to L1, given that it intersects the x-axis at D, find the coordinates of D. Okay, so we know that the gradient here is 2. So L3, okay, the gradient of L3 is equals to negative half. Okay, since it is passes through B, B is 0, 3. So that means L3 is going to be y equals to negative half x plus 3. A intersect at D, find the coordinate of D. D is when y equals to 0. So negative half x plus 3 equals 0. Negative half x equals minus 3. X equals to 6. Yep. Okay. So therefore, D is 6, 0. Hence, find the area of the quadrilateral. Okay, find area straight away, shoelace method, right? Area equals to half bracket. Okay, choose a starting point, okay, A, B, C, D, right? Okay, so B could be a good starting point because it's 0, right? Because it has a 0. 0, 3, go anti-clockwise, there will be negative 2, negative 1. Okay, followed by 0, -7, followed by 6, 0, 0, 3. So many zeros, okay, which is a good thing. 0, 14, 0, 18. So 14 plus 18, right, we will half of 18 plus 14 minus half of the other side, 0, 42, 0, minus 6. Okay, so that will be 16 minus 18. Wait, okay, yeah, did I go anti-clockwise? Yeah, I went anti-clockwise. 0, 3, -2, -1, 0, 7, D 6, 0. Oh, wait, this is -42. -42 and -6 is -48. So it's half of 32, which is 16, plus 24. Right, so it's 40 unit squared. Okay, all right. Okay, is ABCD a trapezium? Justify your answer. Let's take a look again. A, B, C, D, right? It goes like this. Okay, so if this was a trapezium, okay, then line 3, right, is negative half x. So it's definitely not BD and AC, right? BD is not parallel to AC, so we can say it state first. BD is not parallel to AC. Oh, so we make a first claim first. Okay, so now let's find out AB. AB has a gradient of 2. Okay, AB has a gradient of 2. Okay, now let's find out what is CD. CD is 0, 7, and this is 6, 0, right? Okay, so then from the looks of it, it doesn't look like it, right? Because gradient of DC, okay, gradient DC equals to, what was it? 0 minus 6 over, wait, no, okay, okay. Gradient of DC is 0 minus -7, sorry. 0 minus -7 over 6 minus 0, right? 6 minus 0. So it's 7 out of 6. Okay, so equals to 1 whole 1 6. Since AB is also not parallel, okay, then AB not parallel to DC. Therefore, not a trapezium, as no parallel lines.